Welcome to Milan. Weather is not always like that, but this year is incredible. So, and maybe it's related also to something I will address in my presentation. First of all, I'm very honored to do the opening speech to this conference because I think that tinyML is really addressing the key point on the sustainability of AI deployment. Technology is there, technology is evolving, nobody is taking care about the sustainability apart this team. And I think it's very important to have this in mind. So everybody is talking about AI, and in particular, everybody start to be interested in AI from the moment where Gen AI started to come in the picture, because Gen AI is something that is, generating curiosity, what we can do, generating opportunity, fears. And even at G7, this was one of the subjects. By the way, G7 was in south of Italy with a fantastic weather. So usually our politicians know where to go. Engineers, my God, we are here to work. And even the Pope was interested on this new technology, and everybody's taking his angle to look at the technology: ethical, sustainability, opportunity. We are engineers, and so let's stay focused on the engineering dimension of this technology. First of all, let's start from Gen AI. That is what is coming in the picture and is a bit accelerating all the discussion around AI. And I would like to show you which is the impact on the semiconductor industry of the introduction of this new technology. Semiconductor market is a market in the range of $500 billion per year. It is expected to double by 2030 to $1 trillion market, so basically doubling, mainly driven by high-performance computing and cloud, because in the mind of everybody there is this Gen AI that is exploding. And the other side is related to better energy management, so everything that is related to electrification and all of this. But when you look to this number, nobody is considered that all the other markets, whichever is the way you want to call them, automotive, industrial, consumer, you have seen in the picture AI coming in mobile phone. So the fact that there is this big movement around Gen AI will bring this technology in all the devices that we will implement. And I will show you something. So AI is pervading, and for end-to-end sustainability, AI at the edge is becoming important for many reasons. Not only the efficiency, but also privacy. You mentioned the concept of privacy, security, latency. You know better than me which are the key dimensions around that. But then let's start from the cloud, because I want to describe you what semiconductor industry is doing at all, overall, not only STMicroelectronics. So there is this problem, this request of computing, and what is happening? To train the new LLM model, you need more data. The data available now, we start already hearing that they are not enough. We need more data, we need more data, we need more data. Transferring data is consuming energy. But not only transferring data, also working on the data. A query to ChatGPT is consuming 10 times the energy that is done in a normal search that you do on Google. You see the amount of energy that has been consumed to train ChatGPT-4. And if you look in terms of energy, the energy consumption for the data center is expected for a multiplication by 10 by 2026 by respect to 2023. So the normal question is this sustainable? Anyway, technology is developing, technology start, you know, as a semiconductor industry overall, we start to react to the request. And if you look to what is happening in the typical Moore law, you know, there is a big push toward the most advanced technology up to 2 nanometer with gate-all-around, nanosheet, more than 4 performance from power efficiency, because even in the cloud, the problem of the power efficiency is becoming bigger and bigger. And so the industry is reacting to the most advanced device to do AI in the cloud are integrating something like 200 gigatransistor, and we will be soon at 1 trillion transistor in the same device. What else is happening in the cloud? There are other technology that has to come. So because the problem is a real problem, not the speed we are going. First of all, looking, you know, to new architecture. You see, in the past, in the cloud, we had only graphic acceleration. Now network processing, neural processing unit are coming on the picture, maintaining the flexibility. Anyway, in the cloud, the approach has to be related to the brute force. One of the points that start to be addressed is how to overcome, in particular when you process artificial intelligence algorithms, the typical limitation of the von Neumann machine. So that is the memory barrier you all know. Then there is the other point in the cloud. You have to continuously move data to feed those big engines and then to elaborate around those engines. And then silicon photonics is a technology that is coming in the picture. Silicon photonics has an advantage in terms of power because when you move a photon, you consume much less energy than when you move electrons. And the last technology is, let's say, the power management in the cloud. So with the amount of power that is required by those devices, the way you feed the power is becoming important. The latest component from NVIDIA is a component that is sinking 1,000 ampere in one device, 1,000 ampere. You know, it's 700 watt. When you operate at 0.6, 1 volt, it's easy to calculate. You have 1,000 ampere. So we have to be efficient in doing that. This is another area that you can relate it to the effort that the semiconductor industry is doing in electrification, all this domain, to be efficient. In that case, we have all introduced new technology, in particular STMicroelectronics has a strong focus, because ST has a strong focus on sustainability. We had a strong focus to develop the technology to make it everything more efficient, but 1,000 ampere is still a 1,000 ampere. So you have to be efficient in converting it, but anyway, it's there. So cloud, there are initiatives, but the amount of power is still scaling. Even with those, let's say, initiatives to reduce the power, the technology is bringing to a power consumption that may be out of control. So which is the best way to react is really distributing the computing along the end-to-end chain. So the best way to guarantee sustainability is really to move within this path. So having the possibility to properly distribute the processing. I'm talking about sustainability, but on the other side we can see evolution at a given point. The evolution of AI can be stopped because there is not enough energy in the planet to sustain AI. We can already compare the power dissipation of a data center with a small, medium-sized city. Is this sustainable? Of course not. Then is the distribution of intelligence that is the way to go. And at this point, when you start looking at moving the processing at the edge, you start thinking on how we can have this processing very efficient. In this moment, I'm here, I'm in front of you, I'm thinking, what I will say, I'm moving, and my brain is dissipating 20 watt. To do a similar operation, probably, if you do it in the cloud, you will be at least 1 million times less efficient than doing the brain. I consider myself an edge device. So in front of you, in this moment, you have an edge device that is working with very low power dissipation, is thinking, is moving, is sensing, is actuating, but the brain is dissipating only 20 watt. Like the cloud, when I'm sleeping, I still consuming those 20 watt because my brain is retraining what I've been learning during the day. And so if we have to go in this direction, what we have to do? So at the end, you see the difference in a pictorial way. This is edge microcontroller. It was shown in one of the slides. And this is cloud. This is Alessandro. And you can imagine here to have a 7 billion people brain. If we want to bring, today we have difficulty to bring the brain of Alessandro. Imagine if you want to bring 7 billion brain. We don't have to mimic the brain. So how many electronic devices I have on me? I have a watch, I have a phone, I have this device. Imagine that all the computing will move on that. So I manage a device in this moment I'm talking to you. So something has to be done. And your community is very important. You are addressing exactly that. And so the first thing that we have done, so now I come back to semiconductor industry to introduce the neural processing unit within the device to have an implementation that is more efficient. When you do at the edge, you have an advantage by respect to when you do at the cloud. When you do in the cloud, you have to be super flexible, you have to be super programmable. When the advantage that you have when you are at the edge is that any edge device has a context. And then you can optimize what you do. And on top, you enter in an industry field that is used, like STMicroelectronics, that is used to do optimization of the technology. We don't work by brute force. We work by intelligent force, try to find the right solution. So even with a neural processing unit, you can be much more efficient when you do it at the edge. So you have complication, because you have to be small. You have to be super energy efficient, but you have also an advantage in approaching it at the edge. But it's clear if we want to do more, what we are doing now is not enough. We have to do more. We have to go toward neuromorphic, not copying the brain, but let's say mimic or find a way to overcome some of the limit that we may have on that. So the first step is overcoming the typical memory barrier that is in the von Neumann architecture. Von Neumann architecture is fantastic to do calculation. It's less appropriate to do, let me exaggerate, reasoning kind of processing, and having the possibility in the embedded domain to bring the computing very close to where the data is used, you can save a lot in term of energy. And in ST, Giuseppe, that is in front of here, in the ISCC of 2 years ago, has demonstrated really on technology co-optimizing. And here is also the other advantage that you have when you work at the edge. You can optimize on your technology. You don't have to use standard technology that everybody is using. Being able already to reduce 100x the energy consumption by respect to a normal hardware acceleration using this technology. Is this enough? Probably not. Probably there are other technology. I've seen some paper related to spiky, so we wait to have more, more feedback on that. We have to do more, but we are already on the right path on that. As semiconductor industry, we are trying to put together all the toolkit that we are available to move in this direction. One direction is what we call heterogeneous integration. So we take all our technology and we try to optimize the technology for the proper function. Also in the cloud, heterogeneous integration is used. But the focus on the cloud is super performances and flexibility. The focus at the edge is really performances, efficiency, small. I cannot have in my watch a 4x4 MPU. I need something that is small. And here I put a couple of pictures of something that has been developed in ST, one for images, the second one for motion MEMS. And here you see the advantage. Because being close to the source of information, an image is an image. The data you will receive will be an image. If it is a motion, it's a motion. And then you can be more accurate in doing this specific function. And this is the advantage of working at the edge. So we have to keep in mind that we need a complete optimization of the technology if we want to maintain this sustainable. Now, at the beginning, I was talking about Gen AI that was driving, let's say, the picture. There is another important trend that is happening in the industry. A couple of years ago, if I was here, I would have spoken about metaverse, omniverse, virtualization. It was at the hype at the time. And I invite you to think to this environment. When we are talking about metaverse, omniverse, or whatever you want to call it, we are talking about creating a virtual image of everything that is on the planet. In such a way, we can have control of the device from the cloud, or we can have a mix between virtual and real. So maybe sitting during the winter in your room and turning on the air conditioning, putting a vision and thinking to be in a beautiful island. I don't like this. I prefer maybe to take a few days instead of 1 month, but to be in the beautiful island. This was the vision. But also this, it was not sustainable at all, because even in your PC, this is a sort of big graphic acceleration, just if you want to look at it. Even in your PC, you don't pass all the data to the graphic accelerator. You pass the vertex of the triangle, and it takes care to reproduce it. So you work with the virtual model on the other side to do that. And so this was a little bit an hype, but there is an environment where it took place, and this started to take place. It's the industrial one, to control the industry. So in the industrial environment, for many reasons, reconstructing the 3D building of your fab, controlling the flow on your supply chain. But where I would like to put the focus is in the fab, where you control the equipment. And this is very interesting, because here we start entering again in the edge AI concept. So I put this example. If you have a proper model, and if at the edge you are acquiring data, you have two options. Either you send all the data, but if you have the proper model, if you have the proper analysis of the motion at the edge, the proper calculation at the edge, you will simply send the angle, so few data, and the position, and the virtual model can act without moving too much energy. This is related to virtualization. So controlling the machinery is very interesting. And I would like to show some to you, I don't know what is happening, some calculation we have done in industrial environment, why the technology took place. because if you can do predictive maintenance, if you can understand if your machinery is a problem, without stopping your manufacturing line, doing in advance, you can program the repair and not stopping it. And, but if you can't, there is two differences. You can send all the data. Here we have done just the data, just monitoring one motor with a simple motion sensor. You would have sent 30 gigabytes per day to control a single motor. But if you do the processing directly on the motor, and then you apply edge AI algorithm directly on the motor, you will move a kilobyte to megabyte to the central control room. This means to be capable to transfer the meaningful data. You don't need to send all the data. You have to process locally with all the other advantages that you will have. You will stop the machine if something is wrong. You know how many accidents there are on the working place. So there are many, many other advantages. Another case of application of AI at the edge. Now, from industrial, I would like to move on something that is more close to our daily life. This is something that we have already promoted as application of one of our microcontrollers in a simple washing machine, with AI to control the washing cycles. And incredibly, you can save between 15 to 40% of energy. And don't touch the other dimension like water. Water is the other scarce resources in the planet, not in Milan in those days because continuously raining, but and you will be, you don't have problem of I don't know what to say, of drinking water that was mentioned at the beginning. And so, even a simple washing machine, you know what you can say. And this is not communicating. But what is the trend when we combine our technology? We can process at the edge. My washing machine can send information to the cloud. On the cloud, you can do your Gen AI, very complex Gen AI. And then you can retrain the washing machine. You send just some parameter for the AI algorithm that you have implemented. Imagine with all the things that are around. And here is where we combine. When I was talking you, optimizing the end-to-end chain is not only for sustainability, but it's also for better performances. We will have our devices that will become more cognitive, generative and interactive. It's clear that I'm very fascinated by the idea of having Gen AI at the edge because this will improve, but also the scalability on how you process it. I was talking about simple AI, but let's think in a scalable way also what we do with Gen AI. And for example, having Gen AI at the edge will give us new user interface capability. You know, like today, you're right, to have a response. But if your device is there, is learning, is interacting, you can imagine. I'm talking about devices that are interacting. And a question to you, are we very far from this industry? You know, big players are already working around that. You know, as usual, big slogan, boom, we do. But it's evolving fast. Let's ask ourselves why it is evolving fast. Oh, we have standard markets here, cars, vacuum cleaner, and what is the characteristic of those devices? They are battery supplied, so battery technology is evolving. They have the capability to sense, they have the capability to actuate, and we are starting to introduce a different level of algorithm. We are starting introducing artificial intelligence kind of algorithm on those devices. Then, if you are capable to optimize all this technology, it's clear that this evolution is on the way. Given my age that is going on, having someone that will help me in waking up in the morning, in keeping me up would be super important. And now, look at this. I was showing you all the devices around. the planet in a more interactive way with the capability to be generative. Imagine to that, I'm exaggerating a little bit with robot. But I was telling you, consider me an edge device. We all, today, all human, connected to internet, we are helping Gen AI to develop because we are providing the data. Me, an edge device, every day I provide data to train generative AI in the cloud. When we will have all the machinery in the test this capability, you can imagine what we can do. You don't need to be robot, and it's not even something that should be scary. I hope till when there is the switch off button for this technology. But this, what can happen with this kind of technology? Think on that dimension. I was comparing my brain with 7 billion brain in the cloud, exaggerating. Now you can have the idea. So those teeny devices, those small microcontrollers can help really in having an ecosystem that is going in this direction. Now, to resume this first part of the presentation, for sure, a balanced to cloud deployment is what is guaranteeing a sustainable growth. But not only, it's guaranteed to do much more and better things. And what you need to do, we have to optimize the software model and algorithm, and tinyML community is here for that. Most of you are young, is in your hand this future. The same is for the hardware architecture. As semiconductor industry, we are for sure committed to bring this technology with a sustainable path, with the investment that we are doing, and be sure that the effort that this community will do will be sustained by our semiconductor field, in particular by STMicroelectronics. Allow me a few slides to show you what we are doing to sustain what we have seen in my previous presentation. First of all, I'm sure that in this room there are three kinds of developers. There are experts in embedded software, machine learning engineers, data scientists, or embedded hardware engineer. Each of the three categories has different needs. If I'm an embedded software engineer, in particular working in an application company, I would like to have a reference model to quickly adapt it and to put within my device. If I'm machine learning engineer, I would like to work on data at higher level to prepare the algorithm and then to test them. And if I'm an embedded hardware engineer, I would like to have tool, hardware, reference design that allow me to be faster. And overall, this is the world of the people that are working at the edge. I was mentioning a lot before in the presentation the problem of performance, power efficiency, size. I didn't talk about security, we don't have time, but security is another important subject when you work at the edge. But on the other side, in any work of AI-enabled devices, you have always to move from hardware to software, always to move from efficient implemented algorithm to the capability to maintain, develop, and have a new algorithm that are done. And again, I want to come back to one thing. When you are operating at the edge, you have to take care of intelligent sensing, computing, and intelligent actuation. When you are developing algorithms just for the cloud, just the computational model is important. But at the edge, if you want to have the right performances, you have to work on the 3 dimensions. And one of the advantages that we have as STMicroelectronics is that we are probably in the planet the only company that has sensors, computing, for edge. In microcontroller, we have #1 in the field of IoT, and actuation. The 3 key points that you have to consider when you want to optimize an edge device. and understood that we had those technology, we have also a responsibility. So the responsibility is to make this technology available for developer for the edge. So we started, since already a couple of years, to introduce capability, even in a MEMS sensor or a gyroscope, having the capability to have a tinyML supported algorithm that can allow my sensor to transmit meaningful data in a sensor that is a couple of square millimeters. It's not 4 square centimeters and really at a very low power. Then the other thing are the computing. The computing here is not the mega GPU, are microcontroller, microprocessor, and step by step introducing from software to hardware technology that make them more and more efficient to run AI kind of algorithm. This, so we move from microcontroller to microprocessor. And you will see, I think we have the demo, some demo in this room. But the point is, when you work on AI, to connect hardware with software. You remember the picture I showed you? Maintaining the machine learning algorithm, bringing them on the hardware. This is super important, and for that it has been announced at this conference, and we have the demo there. Given the fact that having the 3 basic technology, we have the responsibility, and this is a responsibility for the sustainability, to make the technology easy to use. We have developed a single tool in the cloud that will allow any developer to enter in our suite and then optimize at the edge what we are doing. And this is what the suite will do. I think more than describing the suite here, is better you try it if you have the possibility. But at the center, there is a fundamental tool. And this tool is a tool that allows you either to import your model or use some models that are in the model zoo and then import, analyze, optimize, generate a new code, and validate the code. So you can adapt your algorithm to the specific hardware you want to do. And with the same tool, you can program microcontroller that can be for consumer. You know, we have, I think, more than 600 product family. Then you can decide, depending on what you need for the edge, with microcontroller to address, which microprocessor, consumer or automotive, depending on the characteristic. But even programming the sensor. And why it is important? Because in a single tool, you can decide, I have to do my end, electronic end, I have a sensing element here, I can decide what I process here, if I put a microcontroller in here, what I will process here, what I will process in the local microcontroller, so you partition it, because you save energy, you wake up, if you touch something hot, you wake up the microcontroller, my God, I have to move my hand. And this is what you do at the edge. At the edge, any device has minimum microcontrollers and sensing, or microcontroller actuator, or the 3 functions all together. This is what we want to do with this single tool. Stop here. I don't like to talk too much about ST, but in particular when I have a young community in front of me, I would like to pass really the key message. You know, I consider myself a man of course, I'm a man of the last century. I was born in the last century. And, you know, the progress on the last century has been driven by computational support. The PC you have still in front of you. It's not yet virtual, it's still physical, but one day it will be virtual. Imagine this technology. Time over time, thanks to the PC, thanks to the computing, we have been capable to design microprocessor more efficient. And then we had a computing more efficient, and then we design microprocessor more efficient. Thanks to this technology, we have been capable to design devices that are integrated today 200 billion transistors. And you know, it is a technology that's self-feeded and giving us more and more opportunity. And this was what we call PC. And it was driving the progress during the last century. The progress was very fast, everybody excited, and now we are discussing the impact of this progress. We didn't care since the beginning about the sustainability of what we were doing. So we have put plastic everywhere, and then now we are trying to decrease the amount of plastic, and then we have generated CO2 in the car, and then now we are trying to move to electric. By the way, at the beginning of the last century, there were already electric cars. At the beginning of 900, probably they were developed in parallel for the combustion engine. But we never thought the 7 billion people on the planet can do a big mess if we don't control really the sustainability of the technology. And now we are in the new century, and human progress is driven by cognitive support with AI, no doubt, no doubt. And we have in our hand a technology that is not only a technology, it's a tool. I told you about the computing. Now we have Gen AI, we can use Gen AI to optimize Gen AI, we can use to optimize Gen AI at the speed. I'm not able to forecast what will be the speed. I think what I like at this community is that you are looking on now to have a sustainable evolution of that. How to use Gen AI to have maybe a Gen AI algorithm that is capable to run on a microcontroller. This will be the challenge I will give to you, because I show you there are many beautiful things that we can do after. But keep in mind the two dimensions of the paradigm that we have in front of us. And this will increase the speed of innovation in any field. I wanted to put in this slide, I was mentioning robotics, one of the fields in which I think Gen AI can do something very good is everything that is related to health. Look how stupid are humans. For you it's a little bit less a problem, for me maybe next year a little bit more. You go in a surgery room and there is still a doctor that is operating you in most of the cases, cutting you, sewing you with the hand. Do we have a single device in the planet that is designed by hand, manufactured by hand? Could you manufacture a mobile phone by hand? Is more delicate, is more fragile your mobile phone or your body? So we forget that. For sure, I'm sure, I was talking to you about robotics. I hope in 10 years from now, our surgeon will be assisted in all the operation by this technology, because if the surgeon the night before didn't sleep well, there is my body on the operation. But it's not only that. It's all the progress you can do in medicine. Human body is the only device on the planet, I consider me an edge device. Human body is the only device of the planet that doesn't have a model. We have modelized everything, not the human body. We develop a medicine in an experimental way. We take those 20 people, we test the medicine, the other 20, we take another one, and we see if it works the way we're working. Oh, yeah, Gen AI can help a lot, my God. So there are many good things that we can do with this technology. And also, I think we can use generative AI to repair also some of the mistakes that we have done so far. No? On the planet, we've done big casino. So we can use it for a very good thing. And I think this is my last slide on my presentation. And one thing, you have to be sure that every time you look to sustainability, you are doing something well implemented. Every time you reduce one bit in your algorithm, you are doing something that is not useful only for the technology, but also for the sustainability. I can assure you that ST will be close to you in giving you the tool and the capability to do that. Thank you.